it's about the foreseeable use. It's about the use case, being able to describe the environment, which drives you then ultimately to apply the respective needed and required standard as well.
In this episode of Embedded Insiders, Ken is joined by Heinz-Peter Beckemeyer, the Director of Cybersecurity and Functional Safety Marketing at Texas Instruments, to discuss the EU Cyber Resilience Act and global cybersecurity implementation. Next, Rich and Steve Tadiosian, Infineon Technologies Senior VP for the IoT, Compute, and Wireless Business Unit, discuss industrial power conversion in the data center. But first, Ken and I briefly share our thoughts on the impending EU Cyber Resilience Act, which will take full effect in December of 2027. Hello, everyone, and welcome back to the Embedded Insiders podcast. I'm Assistant Managing Editor Tiara Oliver, joined as always with our Editor-in-Chief, Ken Briota.
Hello, Tiara. How are you today?
I'm good. How are you?
I am all right. It's starting to feel like spring, and that's always a good time.
Oh, thank goodness.
Are you still trapped in the horrible, endless 100-plus degree heat wave?
I am. There was no spring for us here in Phoenix. It just went straight to summer, and we're not even at its peak, so I'm quite afraid for that. But what's new?
I did read yesterday that the heat bubble is moving, and so you might get a reprieve. I hate to tell the people in the Midwest and South this because it is coming your way, according to what I read yesterday.
Sorry to them, but we are safe.
I really hope it doesn't come my way.
Yeah.
I'm not sure I would survive. I don't usually even put the air conditioners in until June.
Oh, wow. That's nice.
I mean, it's cruel and unusual according to my children, but
yeah.
But I stretch it as long as I can.
Mm-hmm. Makes sense. So
I wanted to talk to you a little bit about an interview that folks listening are going to be hearing in just a moment that I did with Texas Instruments about cybersecurity in embedded, and specifically the upcoming CRA, the Cybersecurity Resilience Act, that's going to take effect in Europe, in the EU, much sooner than anyone is really ready for, I think.
Yes. And we just left not too long ago. We're at Embedded World, and I know we touched on it a few times. We had our conversation, but we also talked about how the meetings that we held, that was brought up quite a bit, and people were feeling a way about it. So,
oh yeah, I think there is a tiny little cottage industry of companies helping their partners get compliant ahead of time. I mean, as I read it, the Cybersecurity Resilience Act is mainly aimed at new devices that are to be released after it comes into effect. But yeah, people are nervous because this is obviously EU is a big market, and at Embedded World, which takes place in Germany, obviously it's a huge percentage of the market for a lot of the companies there of their market. One of the things that we discussed on the episode that you're about to hear that was really interesting is that there is not a lot of provision in the CRA, and because it wasn't intended for this, for legacy devices. And historically, that's where a lot of the cybersecurity vulnerabilities live. The new devices are protected against the new threats, hopefully. It's the legacy and older devices that have the vulnerabilities. And so TI is part of an effort to create some amendments and some study around adding that to the CRA, actually.
Yeah, I thought it was interesting that obviously this was brought up a lot, and security is always something that is also brought up a lot. But I mean, as far as I know, was there anything not already in place before the CRA? Like, is this some super new cybersecurity provision, I guess?
No, like there have been other cybersecurity legislation in place in the EU and elsewhere. I think that this is much broader
Gotcha.
than
Okay.
previous legislation has been, and regulation has been very specific to industry. You know, this is for automotive, this is for rail, this is for train, this is for airline, this is for freight versus passenger, this is for, very specific regulation, or the regulation is very specific to technology. This
Hmm.
is quite broad, and that's how I see it, as different. Um and as I read the bill, or the proposed legislation standard, um, I think that they've done a good job of like calling out these specific cases where folks are going to go, well, what about me? What about this? But there's going to be growing pains. There's going to be elbow room, I think, and it's going to be a big deal. I think it's going to be a lot like GDPR was when that came into effect, the privacy regulation that also the EU put in place, God, almost 10 years ago. Might have been 10 years ago now. And That was a big deal at the time, and everybody was very nervous about it. And getting compliant with it was a big lift for some companies, but everybody did it, and it worked out well.
Yeah.
Um, now, if you travel around a little bit, as we have done, and you use the internet, or in the EU, or you use EU-based websites at all, you notice they give you a lot more choices in your privacy concerns than we here in the US are used to. And that's entirely as a result of GDPR. So it's very interesting.
Yeah, very interesting. And I mean, there's really nothing negative about having more mandatory cybersecurity requirements for hardware and software. So at the end of the day, it's a good effort and a good move forward in the right direction is what it sounds like.
I mean, I agree. As we get closer to the post-quantum era and the quantum computing era and all
Hmm.
these kinds of uh, sort of next generation compute, the traditional cybersecurity methods just aren't going to work, and we need regulation to be ahead of that curve, not behind it. Because your whatever it is, 12-digit password is not going to cut it anymore in a post quantum era to protect your stuff. You're going to need to be a little more clever than that, and I think that's part of what this CRA is attempting to anticipate. So I encourage folks to listen on. There's a lot to hear on this, and we talked about some of the interesting issues, but certainly not all. So keep up with all the news um, on embeddedcomputing.com and on YouTube, wherever your finest embedded computing design content is found.
Yes, and this next interview with Texas Instruments will be live on YouTube video version. So be sure to check that out and stay tuned.
Incredible. Thank you so much, Sierra. You're the best.
Now, here's Heinz-Peter Beckemeyer, the Director of Cybersecurity and Functional Safety Marketing at Texas Instruments.
Hello, friends, engineers, and developers. Welcome to another episode of Embedded Insiders Podcast. I'm Ken Briota, Editor-in-Chief of Embedded Computing Design, and today we're going to be talking about security. I know. Sometimes you have to eat your vegetables before you get to the meat, and we're going to talk a little bit about some vegetables today, but I think it's going to be really exciting thanks to my guest, Heinz-Peter Beckemeyer, who is Director of Cybersecurity Marketing at TI. Welcome to the program.
Ken, thanks a lot for having me today, talking about cybersecurity. We are in an exciting days, I would say, when it comes to the cybersecurity law in the EU, the Cyber
Yeah.
Resilience Act.
Yeah, I generally shudder at the thought of a cybersecurity expert telling me that we're in exciting or interesting times. But you're right. The EU Cyber Resiliency Act seems I mean, that's the big story. I just got back from Embedded World at time of recording here, and I think you were there too. And that was, man, almost all that people wanted to talk about was getting ready for that and making sure that everything was compliant and stuff. So let's start there. Are you anticipating any bumps in the road with that? I mean, that comes into effect in September, is that right?
Yeah, let me go one step back and talk a little bit about the CRA.
Yeah.
So basically, the European Union came out with the Cyber Resilience Act in December 2024. And within 36 months, this law will basically get into application. So, and let's talk briefly about the CRA. So the main purpose of the EU Cyber Resilience Act is to make digital products more secure by design and throughout their entire life cycle.
Yeah.
And it aims, which is the good thing, there is the good intent behind it. It aims basically to protect users and businesses from cybersecurity risks by ensuring that products, and here this will be the important piece we will talk about, products with digital elements, they will have to be secure when they are sold. They will have to be maintained with security updates and with a transparency about vulnerabilities. So that's in a nutshell the description about the CRA. And when I said earlier exciting, you can say interesting, exciting. There are very interesting times in these days when it comes down to what do we as a semiconductor supplier have to do? What do our customers have to do when they integrate our components? So I'm sure we will talk about these details here in this podcast, Ken. Yes.
It sort of reminds me a little bit of the GDPR regulation from almost a decade ago now, right? And how you sort of led the way and the rest of the world followed. Do you anticipate a lot of the rest of the world implementing similar regulation as time goes by?
I would say this is definitely the first time you can see that there is a regulation down not only to the product, it is down to the product and even down to the component inside the product, if the component has a digital element. So that's the first time you basically see this, and it's kind of disruptive, I would say, when you look at this and when you see what companies throughout the supply chain have to do to get their portfolio to a compliance stage. I'm sure we know cybersecurity as a topic in itself is becoming more and more important, and for sure, I think we will see the sprouting as well. Whether it's going to be like the CRA, we will have to see, right? When it comes down to the compliance and conformance level down to a component of the product, because this is portraying several challenges out in the industry here, for sure.
Yeah. I mean, I know TI is a huge asset to their partners and helping out, making sure that your partner companies are getting there, and TI's obviously putting all the pieces in place to be compliant themselves. What are some of the sort of more difficult parts of the CRA to comply with? Have you bumped into any? Is it all pretty easy, or have you bumped into any roadblocks?
Yeah, it's a very good question, Ken. And I can tell you, starting from analyzing and studying the law, definitely there have been several items to tackle. And I can tell you, Texas Instruments has taken the Cyber Resilience Act very seriously from day one when we had the law out, studying, assessing details and implications. One very big challenge has been from day one around the topic of legacy devices. So when you look into the CRA law, there is no legal path for legacy devices out there. And when you look at the CRA law talks about the 22 essential requirements, and there are requirements which are down to security by design and secure by default. Now, we obviously, as I explained earlier, we would like to get to the security level where we protect users. A device is powered up and it comes with a secure by default mode. It comes with a security by design. But when you look on the component level, it's a big challenge, obviously. We have components, when you look at Texas Instruments, we have about 80,000 products. When you look at the law, it talks about products with digital element. So we need to look at our products at the end, which have a digital element. And we are in the ballpark of 50,000 products which are in scope. And what this means at the end, what I mentioned earlier, the law doesn't provide a path for legacy devices. So that's been a big challenge which we have seen from day number one, and we've been tackling this. We've been in the lobbying effort as well. We've been with multiple different industry associations. We've been in conversation with the ENISA, which is the European Union Agency for Cybersecurity, and alongside with the industry association called the ESIA, the European Semiconductor Industry Association, and its members, we are lobbying into the EU Commission, or we've been lobbying into the EU Commission for getting to a path for legacy components.
Because obviously those kinds of updates aren't all doable over the air, and not all those legacy components are accessible that way either, I would imagine.
That's correct, because when you look at products with digital elements, you get down to very simple products at the end.
Yeah.
I mean, a logic gate by definition is a product with a digital element, but we obviously want to be able to ultimately categorize the products accordingly, to look at them in the light of their the security risk, right? And we want to look at the foreseeable use, at the intended purpose as well. And that's important. And again, this was not given to start with by the law. And we've been in this lobbying effort, and we are still in. And as a matter of fact, we had this month in March, we had now a guidance document from the EU Commission, which was published, which is right now in the draft and inquiry phase. And we've achieved to have statements now about legacy products in there. So products which were designed before CRA gets into application. And that's
because CRA, as I read it and as I understood it, was very initially targeted at new devices. New development has to follow these regulations, and they didn't really address any of the legacy infrastructure. But that's where I'm no cybersecurity expert, but in my experience, when I've seen these things happen, it almost always happens through a legacy device that was built before there was a new, access point or backdoor or something that a bad actor could work through. There was a new method invented that older devices didn't have a way to cope with. And so I think that this approach of building a roadmap, a path for legacy devices makes a lot of sense. And it will help a lot of companies other than TI also. So good citizenship for you guys.
Yes.
When it comes to larger cybersecurity issues, what are some of the things that engineers out there should be thinking about in their designs? There's the basic nuts and bolts of good security design and good, basics and stuff, but this is an always moving target, isn't it? What are some of the things that designers and engineers should be thinking about these days?
Well, I think at first things start with the categorization. And again, if we stay with the CRA, the Cyber Resilience Act, You have basically in the Cyber Resilience Act defined product categories. And there are 4 different product categories at the end. There is the default category. You have what's called an important class 1, you have an important class 2, and you have a critical elements category. And I think the first thing is to think through your foreseeable use, your intended use case, right? And this way it puts you into one versus the other category. For a default category, here basically as a company, you can basically do a self-assessment on your product, right? When you are on the lighter side. Once you know you're on the critical side, this is maybe a smart card, this is a smart meter gateway, right? So you will have to resist obviously tighter standards, which are being developed. These are called the harmonized standards as well. And I think you need to know where you are, right? Which type of attack, which type of resistance you need to provide. And I think that's where it starts with. And that's also where ultimately, I mean, security is not security, right? So there is a different level, obviously. And you might have a case where your product is encapsulated, and you might have no one can access the device. You have to maybe only an intrusion you can get to a component, right? But your point earlier, you might have cases where you have over-the-air updates. This is completely different, obviously. So it's about the foreseeable use. It's about the use case. It's about being able to describe the environment, and which drives you then ultimately to apply the respective needed and required standard as well.
It used to be, I've been writing about and reporting on security for a long time, and I started out really in IoT spaces, talking about security, where a lot of times there it's network security, it's network mapping, it's identity and all that sort of thing is where you start. And there's always the risk of a bad actor, but more often than not, it was an accidental thing. It was a data leak, or it wasn't a bad actor who was trying to steal data that was the security concern. It was a accidental release of data, or a human error that just sort of opened something up. Is that still the majority of sort of cybersecurity risk, or is that balance shifting?
I guess when you look at the CRA, the way it's written, the reason why we will see CRA from December 2027, I think it is shifting, right? I think we will face situations where products are at the end are being attacked, and I think we need to be prepared. And again, like I mentioned earlier, like TI, we're driving this to the depth, to the level of understanding what we need to do to prepare also our customers at the end to do the right things. And this comes with when you look at our products, for instance, the one side is obviously you're compliant. You have maybe ultimately you will have to have a CE mark on the products, right? But ultimately, it comes also with the right level of information, and this comes with the technical expertise, obviously, which we will bring in. It comes with the right level of documentation. You will have risk assessments. This will allow customers ultimately to design a product which can withstand attacks in a certain environment as well. Again, you have the spectrum, right? From fully encapsulated up to over-the-air updates, where you have obviously a full accessibility. And I believe, again, this is shifting. We need to help our customers here being prepared for the right security designs.
Yeah, absolutely. It was, I'm sure you already know about this, but in case some of our listeners don't, there was a very terrifying and interesting breach in Linux that was reported on, not terribly widely, but was really interesting. And just, I just heard about it in about 2 months ago, but it was initially reported last fall, where there was somebody spent months and months and months getting involved in the Linux community just to insert a little bit of code that allowed them to have a backdoor into any Linux operating system anywhere. And it had to do with one of the libraries that just everyone uses. And when you think about that, that's the kind of thing that's terrifying, right? Like that somebody will find a way, and it got caught just because somebody else went, oh, that's weird. It's taking a millisecond too long to perform this operation. Just some random person noticed that and they thought it was their code. So they started following it down and looking for a bug. And then they found this massive, huge bug that, and whoever created that is out there. Nobody caught anybody, you know. So it's those are the kinds of things that worry me in the cybersecurity world. It's like so subtle and they're so patient. What are the things that keep you up at night? Because that's really going to scare me.
Yeah, for sure. I mean, these cases, and we could spin this further. What's to come with PQC, post-quantum computing as well, right? You mentioned the time it takes, right? So in we don't know exactly in how many years, right? But the time will shrink until you can hack, right? And so I think that's an important thing to have on the radar screen, and we need to work on this today, basically. What keeps me up awake at night, for sure, in the last couple of months, in the last 1 to 2 quarters, I can tell you we've been spending so much time in making sure we get the right, like I mentioned earlier, the guideline from the EU Commission. I mean, it could ultimately, ideally, it would be a change into the law, which might not happen, but the guideline will already help. This was so important, Ken, that we made, also we STI, that we made this progress with the Commission as well, and together with the ESIA, that ultimately this would have led into a massive supply chain disruption.
Yeah.
Again, the comment on the legacy products which I made. Obviously, we can talk about all the most severe security attacks, but if you even cannot build a product because you don't get the semiconductor components anymore, because the fact is the parts which we cannot CE label, which theoretically have to be labeled, we can't sell them anymore, right? So therefore, we have to put all the effort into it, and therefore we're taking it so serious. And this has kept me awake for sure.
Well, I mean, we spent a good portion of the last 5 years finding out exactly what it's like when the semiconductor supply chain gets disrupted, and nobody wants to go through that again. In a sort of broad sense, I felt like this year was a great vibe at Embedded World, because I think people feel like we're past that now and the supply chain is back to what people expect and need and able to meet the needs of what people want. I certainly don't want to be in a situation again where that disruption that you're talking about happens because of a lack of compliance or cybersecurity risk. That terrifying.
Absolutely. And again, therefore, we put all weight in there. And also for this reason, I'm leading at our company a task force to make it happen as well. And starting from, again, studying, assessing the law into the lobbying effort, and ultimately to get down to all the required documentation assessments as well, and to make it happen.
Yeah. As we get near the end of our time, I like to ask everyone the same final question. What is it that I didn't think to ask you that the listeners should know about CRA and about the work that you're doing in TI for cybersecurity as they're out there developing? What should they know that I didn't think to ask you?
I think I have, in these days, I have more customer meetings around this topic like I've ever had in any other area. I think the listeners, the audience should know this is our day-to-day drive to make things happen. And also the audience can stay tuned to how we apply our strategy for the compliance as well. And our message out there is we are driving for a conformance of our portfolio to CRA as well in time. And that's what the audience out there should know about Texas Instruments and how seriously we are taking it.
Incredible. And of course, that's really no surprise to hear how seriously you're taking this. Thank you so much for taking the time to chat with me today, Heinz-Peter. Really great to pick your brain on this really complex and important topic. So thank you.
Thank you, Ken. Thank you for the time and opportunity as well.
The pleasure is entirely mine. And as I've just found out, the listeners. Folks out there listening, thank you so much for joining us for this segment of Embedded Insiders. Don't forget to subscribe wherever your favorite podcasts are served up. Or if you're watching this on YouTube and you're not subscribed, and I know some of you aren't, please make sure you subscribe and hit that bell so that you never miss any of our episodes. Thank you again, Heinz-Peter. Thank you to TI. And thanks to all of you who are listening. I've been Ken Briota, Editor-in-Chief of Embedded Computing Design, and your host. Have a great day.
Now, here's Steve Tadeusian, Infineon Technologies Senior VP for the IoT, Compute, and Wireless Business Unit.
Good afternoon. I am Rich Nast. I am with Embedded Computing Design. My guest this week is Steve Tadeusian. He is the Senior Vice President of the IoT, Compute, and Wireless Business Unit at Infineon Technologies. How you doing, Steve?
I'm doing great. Thanks, Rich.
So I'm giving a gold star to myself because this is like the third or fourth time that you've been on the podcast, and it's the first time I've pronounced your name correctly.
Yeah,
so,
you did well. Thank you for that.
I get a pat on the back for that one. We've talked about lots of things in the past. Today, the topic is industrial power conversion. Because I know you guys are pretty active in that space. So just to set the baseline, what is your definition of industrial power conversion? What are we talking about here?
Well, we're talking about primarily, I think, with our newest products, AC-DC power conversion, but in addition to that, DC-DC conversion for different loads in a wide range of industrial systems. I think obviously the hottest market right now is around power supplies for AI cloud support. So it could be data centers, but in addition to that, we're talking about telecom, wide range of industrial applications for power supplies and UPS systems. And then if we look at photovoltaic, it could be microinverters or string inverters, could be your AC-DC charger in your garage, for example, for your electric vehicle as well. So a wide range of kind of use cases, but in the end, it's all about converting power that's coming from the wall into something useful by the end product.
And what is the level of power that we're referring to here?
So this is a great question because it's changing almost every day right now. So if we looked back maybe a couple of years in terms of like a data center, you might see a 2 kilowatt PSU in those systems. Today, you might see a 5 kilowatt system. And what we see in design now are 8 and 12 kilowatt systems. So needless to say, and I think it's pretty prevalent in the news, those data centers can consume a lot of power or energy. And how do you minimize that is a big trend in the industry right now. So making those systems more efficient, operating at higher power levels, and converting that power in a more efficient way.
Okay, so I'm going to take this out to what used to be the extreme, which is now the norm. These data centers are consuming, I was going to say ridiculous amounts of power, but huge amounts of power. And it's at the point where it's a problem. And there are many states who are not welcoming these data centers just because they take too much power and they just don't know what to do with them. Are these real concerns? And is there some sort of solution on the near term?
Well, I think those are real concerns. And I think the solution here is to continue to work on system efficiency. And that's from the power generation all the way through the consumption in the data centers. What we are, well, I don't want to say as Infineon primarily focus on, because we support that entire chain from power generation to power consumption, and with a range of power devices and microcontrollers to manage those loads in the most efficient ways possible.
Is the solution to produce more power, or is it to reduce the need, if you know what I mean? Have lower power consuming devices, or both?
I think it's going to be both.
Yeah. And is there just enough power to go around?
That I don't know. Like you're outside of my area of expertise there, Rich.
Okay. All right. So say we were having this conversation a year from now, what would we be doing? Is it just the same devices getting incrementally better, or is there something revolutionary on the horizon?
I think what we're seeing is already a pretty significant change is happening, I'll say right now, in this field. And that is this conversion on the power side to wide bandgap power devices, like GaN and SiC, for example. And that is enabling much higher switching frequencies in these power supplies, which is driving up the overall system efficiency. Now, to control those devices, though, there's also a change that is happening real time right now in terms of the microcontrollers that are used to control those systems, because they need to support those higher switching frequencies in an efficient way and in a reliable way.
There's always a number where we say, okay, this is where you use silicon carbide and this is where you use GaN, and those numbers move a little bit, but they don't seem to be moving a lot. Do you see those numbers staying the same? Where, and I don't know off the top of my head what the actual numbers are, but it's like up to 400 you'd use silicon carbide, or I'm sorry, use GaN, and then above that you'd use silicon carbide. Is that still sort of the rule of thumb?
I think so, but I think, as those technologies become more mature, I think you'll see more and more innovation in both of those areas that will broaden their applicability.
And is there some other chemistry out there that we should be looking at?
That's a great question, and I don't know the answer to that one, frankly.
Okay. Where is Infineon in all this? I'm sure you guys aren't sitting by the side and just watching what's happening, because you guys are one of the leaders.
Yeah, so this is a really fast-moving market, especially right now, and we look at this as an overall system, and we think that approach helps developers get their products to market faster in a fast-moving market. So we look at, again, on the power side, how do we bring industry-leading devices to help them get the best efficiency out of their systems? And then on the control side, how do we bring microcontrollers into this space that are able to deliver the capabilities to support those wide bandgap devices, for example? And it's not only about the hardware, of course, which I think is also, by the way, I'll just a side comment here. I think this is a really interesting space because it, in a lot of, say, digital applications where my group focuses on the microcontroller side, it's mostly a software effort. And not to say that there's not a heavy software lift here, but the combination of the hardware and the software working together seamlessly is not only critical. This isn't about your PC rebooting or your doorbell having an extra, half a second of latency in it if there's a software glitch. This is about, really, frankly, potentially dangerous situations evolving if these systems from a hardware and software perspective aren't rock solid. So it's a unique developer, I think, that takes on these system solutions. The other piece of this then that we offer beyond the hardware are specific software tools. We have something called Power Suite to help developers rapidly configure their designs, as well as a set of power conversion libraries for various topologies to help them to move faster to market and deliver a robust, reliable product at the end.
So to be clear, these are software tools that are used in the design of the system, not while the system is functioning. We're not doing dynamic things, are we?
That's right. That's right. What we're providing is the software tools for developers to develop the system. What runs on the device, we do provide power conversion libraries and other, call it like telemetry software around how the system is operating. At the end of the day, if there are things that the developer decides to monitor and adjust real time, that's in their application code, of course.
Okay. Infineon just had an announcement recently in this space. Can you go through that quickly?
Yeah, so what we're announcing is this new tool power suite. So we have a set of new devices very specifically targeted at data centers and telecom PSUs, so that are adopting these wide bandgap devices. And those those microcontrollers then need the support in terms of the tool chain and configurators for developers. But it goes beyond that. Like I said, there's software libraries for power conversion for PFC, range of topologies, for LLC, half bridge, full bridge, for example. So what you would find in a power supply design. But in addition to that, there's a whole suite of visualization tools as well, so that developers can see what they're or when they make changes, what the implications of that is real time as well during the development.
This is pretty interesting because back in the day when I was working on power systems, it was somewhat of a brute force, generally analog, and you just matched up the components and everything sort of worked as close as it needed to. Now you're into a completely different space where you're using software to design these systems. So has the role of that power engineer, from the system side, the power engineer, has that changed dramatically? And is he more of a software guy? God forbid.
So it's happening. It's happening. There's still certainly experts, I'll say, on the say the more traditional or specific power design and hardware design. And this is where I was going earlier in terms of, like, it's really a dynamic system that both sides of it, to get the most efficiency out of the system, need to be understood and then tuned well. And I think what we are doing helps developers move out of I don't want to call it trial and error, but like you said, put things together, see how it works, maybe tweak the hardware a little bit this way or that way, change this component, see, do I get something better? Move or a lot of that tuning into the digital world, because now you have digital control of the power conversion, and then be able to make those adjustments in more real time, but also bring in things like simulations into your code base as well, that you've done in simulation tools for model-based design, for example. So I think, to answer your question shortly, yeah, the role of the power engineer is changing. And I think for those that are going to get the most efficient designs at the end of the day, are gonna be able to understand how to leverage these latest and greatest tools that the industry has for the software development aspect of it.
What's the learning curve for a tool like that?
So for our tool power suite, frankly speaking, the learning curve is pretty low. It really is a configurator. So I think most configuration options in there, I would say a more traditional hardware-based power designer would recognize those things and be able to understand what they were configuring in the system. And that's really what one of the aspects we're trying to do is meet the designer or the developer where they are, and bring them into this other world as applicable. So they don't need to open up a terminal and start programming in C, for example, or open up Copilot and tell it what to program for them. They can make that transition from a traditional hardware design to one using digital control.
Boy, did you just open up a can of worms there. Maybe we'll save this for the next podcast, but
sure.
Do we even need the person to do that anymore? Just plug that stuff into AI and say, design this thing for me?
I think you still need the person. There's still a lot of other work to do other than the base code generation, at least for now.
I'm offering an invite to you to come back for another podcast, and let's have that discussion, because boy, is that interesting. Not only interesting, it's scary.
Yeah. There's a lot of interesting stuff happening in that space right now, as I'm sure you're aware.
Yep. Thank you, Steve. This is very cool stuff.
Great. Thanks, Rich.
And you're making power cool again. That was Steve Tadeusian. He is the Senior Vice President of IoT Compute and Wireless Business Unit at Infineon Technologies. And I am Rich Nass with Embedded Computing Design.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.